What is up, everyone? Welcome back to another stream. Today we are going to do some hacking, some in-depth transaction hacking, because we have some issues in our own blockchain. But first of all, I'm going to tweet and notify that I'm live. So basically, we are creating our own blockchain in Golang, a complete blockchain from scratch in Golang. And we are at the point that we almost are done. But we were testing our own currency, our own transfers, native transfers, and we had some issues with our transactions. So it would be a good thing to actually test all these factors and see if we can fix them. Yeah, that's what we're gonna do. That's the plan of today, transaction test. So basically, where is this test? Let me find this thing. Oh, it was blockchain test actually. It was a little bit more depth, a little bit more integration. Akan, these streams are on steroids. Yes, man. Yeah, we are producing content against the speed of light. That's what we do. No time to sleep. We have no time. Test native transfer success. Yeah, here. So, yes, exactly. Test send native transfer tamper. So what happens is we are basically creating a transaction where we're gonna send money from Bob to Alice, right? Classic crypto shenanigans. So we do this. We create an account, key pairs, private key, all that good stuff. We create our transaction. We put a value inside of it. We're going to transfer 100, whatever, rupus, whatever you want to name it. We're going to sign the transaction with the private key of Bob. Then we are going to create a private key for the hacker, right? For somebody that wants to tamper with the transaction. And we are going to change the address of the recipient. We're going to add that block onto our chain. And that should be Gucci, not Gucci, and that should give an error. And right now, it isn't. So there's a lot of stuff going on actually also, these random log lines, we need to fix these actually. We're gonna do this real quick. Let's go to blockchain. I think we have state printed out somewhere. Let me FMT. I think we have the Coinbase printed out, yeah. Interstellar, welcome, man. How are you doing? How is your weekend? So let's delete that log line. And we also have, let me see what we have. And these two lines, what could it be? I want to get rid of them. Maybe validator. Not validator, it's going to be... Can we do smart contract security course in the future? Yes, sure. Very important, very important. I'm making these series about the full stack decentralized exchange, and I'm going to cover these some potential security issues, the most common ones. But most of these issues in the DeFi protocols are not the smart contract issues, right? Because they are getting audited and they are pretty good firms doing that. But the most problem is token economics. That causes, it's the evil. Token economics, because you cannot test token economics that much. So it could be that if somebody has too much, whatever, if some pool is getting, you know what I mean, right? You never know. And then you have edge cases, and that's exactly when problems arise. All right, so yeah, it doesn't matter. That logline, if we see something that need to be deleted, we're gonna delete this. Right, so the problem is, let us do some in-depth logging real quick. So we have these Printf's here. Do we want this? Let's delete these. Let's delete these and see where we at. Let's do fmt printf. I'm gonna say Bob. It's going to be priv key, the private key of Bob. Not the private key, the public, the address actually. The address. So we can actually compare it in our state, right? Because we're storing balances in our state. And then we can compare. We're going to say Bob, Alice. It's going to be Alice priv key, pub key, address. And then we're going to say the hacker, right? The hacker is going to be hacker priv key, capital key, K. All right, so look at this, right? Look at this, I'm saying, but oh yeah, it's here. I'm wondering. Yeah, of course. A classical thing. New lines. New lines. Man, what is this cursor doing in my thing? New lines here, new line here, and a new line here. Right? Okay, let's go. Boom. Yes. So we have Bob, and Bob should have 0 balance, which is true. Alice should have 100 balance. Alice is not even into the. Yeah. Alice does not play because we didn't create an account because she didn't receive any tokens. But the hacker, you see the hacker is in the state and the hacker has the possession of the 100 tokens. Ice Bear, what's up? Welcome once again. And that's not good. So we could do a lot of things to fix this, but we need to go back to the roots. And we're going to open up our transaction test. NFT transaction. That's not what we want. We want test verified transaction. Actually, you're gonna make a new one. Func test verify transaction with tamper. Yes, we're going to say testing. It's going to be testing. My hands are still sticky. Testing T, and we're going to say TX is going to be a new transaction. We're going to say null for the data because we don't have a smart contract, and we're going to say TX. Let's generate some things. From priv key is going to be crypto. Generate priv key, and we're going to copy this 3 times. We're going to say 2, and then we're going to say something is happening in the chat. Some cam girls are showing herself, but Nightbot is taking care of all this nonsense. Priv key, and then we're going to say this is to priv key from, and then this could be hacker, whatever. Hacker priv key, right? Why can I not? Yes. Then we're going to say tx from is going to be the from priv key, but the public key, of course, because hey. Then I'm going to say tx2, which is the recipient. It's going to be to priv key, and then we're going to sign the transaction. Oh wait, we're going to say tx value, which is the amount. It's going to be 666, and then we're going to say tx sign. We're going to sign this transaction. Is this true? tx sign. No. We're going to say we're going to say tx sign with from priv key, right? Because if we send the transaction, we need to sign it ourselves. maybe we could do an assert on this real quick. Assert null t, and then do this. So that's Gucci. Of course, we have this hacker priv key. Let's comment this out. And then we're going to say assert nil, right? Nil means no error, right? Error should be empty. We're going to say tx verify. We're going to verify the transaction, and that should be nil, right? Because there is literally nothing wrong with this thing. You see, it's working. But and I spotted already the most filthy issue you will ever encounter in your life. I spotted this. I will show you. It's very nasty, but Matrix is trying to distract you also. Yeah, exactly. Interstellar. They're trying everything to stop us, but they just can't. They don't realize it. They can't. It's impossible. Nobody can stop us. Literally, no one. It's... you need to keep me alive, though. You need to keep me alive. That's the thing. So, yes. So what we're going to say? We're going to sign. Where are we signing? Here. We sign the transaction here, right? And then we're going to say that the TX2, right, is going to be the hacker priv key, right? That it could be that somebody is, you're forging a transaction in the front end. You send that, I don't know, to some node, but some guy has some malware which basically injects his address, or even the most common hack, basically back in the days, was a Python copy pasting. It was a Python script that basically lived on your computer, and each time you pasted a Bitcoin address, right? It was a clipboard hack. Each time you pasted your Bitcoin address, it replaced your address with his address. Genius. But yeah, something like that, right? These guys, yeah. I'm copy pasting addresses all the time, right? So you need to double check. And also be careful if you download packages with NPM and all that stuff, because it's full of hacks, right? So TX2 is going to be hacker priv key. Public key, right? That's that. So we signed it already, but we tamper it. And then we're going to verify. Look, this is mistake number one. This is already a problem, right? It's passing. This should not pass, right? Our coins are gone, right? So we actually hacked our own chain because we made mistakes. That's why testing is important. So that's not good. But where is the problem? Where could be the problem if you think about this? It's all about hashing and signing, right? So we need to check these two. So we are going to the hasher. Do we have a hasher or something? Let's open up here. It's easier to read for you guys. Hasher. Yes, here. Hash will hash the whole bytes of the TX, no exception, right? And that's not good. Because if you open up transaction, we're basically hashing this whole thing. And that's the first thing I'm going to change. Because I only wanna hash this TX inner. Also, of course, we're going to hash that because we need that for our native NFTs. But it's an any. And we're going to fix that soon. But for now, we don't need this because we are not gonna use it. So I need to fix this real quick. So instead of doing this hop encoder, can I make this higher? Yes. So what we're gonna do is we're gonna do some binary operations. Little endian. I will explain what that is, little endian, for the people that don't know. So we make a buffer, that's fine. But then we're gonna say binary, right? We're gonna give the buffer. Then we're gonna say binary No, I think it's, wait, let me quickly check what the write does. Nothing. I think it's buff and then binary little endian. And then we're gonna say, first of all, data. We're gonna say tx data. Yeah, it's working. I'm gonna copy it a couple times. Buff binary little endian. What is little endian? Little endian is the byte order of bytes in memory. It is, you have a little endian and big endian, and it's just reversed. Little endian, and then big endian is just the other way around. And it depends on your CPU. Not quite sure. I can go in technical depth, but in technical deepness, but I don't know exactly what processors use what kind of byte order. But I know that the most common one is little endian. Correct me if I'm wrong. We're using a little endian. It does not matter because as long as we know that it's little endian, it's good, right? Everybody needs to follow our protocol. So we're going to say data and then quickly going to say tx2 because 2 is a public key. And if we open up public key here, we can see that public key is a byte. So it's easy. We can just do this. We can just put it in because we're writing in a buffer, bytes in a buffer, right? tx data. Then we have to value, right? The value that we're gonna hash the value, we're gonna hash the from, and we're also gonna hash the nonce. We're not gonna hash the signature. It literally has no point to do that. We don't need to hash the signature, and we don't need to hash. Yeah, we don't need it. So data to value from nonce, and these are returning errors, but they won't return errors. And if they return an error, the thing is broken and it will return an error somewhere else because we cannot. The hash will be invalid, right? And if it's invalid, the transaction or block or whatever will not be accepted. And then we're going to say, we do a simple SHA-256 of the bytes of this buffer we just write in, whatever that thing is, what I want to say. All right, that's it. So if you go to transaction, back, test. It's not going to solve it right now, right? Or maybe it will. Where is this thing? Here. It still works, right? Where do we verify this transaction? Look at this. Probably there. Transaction. Here, verify. Can you see this? Yeah. So we say, first of all, if the signature is nil, of course, if it's not being signed, it's going to return an error, right? But here, what we do is takes data, because in the beginning of our series, right, where we're creating this blockchain, the only thing we actually had was our data field. We had no nonce. There was no native implementation of currency. And we agreed upon that if we just hashed the data, it was enough, right? If we hashed our contract or arbitrary byte slice, arbitrary data, bytes. Oh my God. So of course it's going to be true, right? I mean, we need to fix this. So what we're going to say is we're going to take the hash of our transaction. We're going to say takes hash, and it needs a takes hasher. And we are not calling the hash directly from our transaction. We are actually calling a function that will check if there is already a hash calculated. We will return that, and if it's not, we will calculate the hash. Some kind of a caching system, right? Because if you have a high-speed blockchain, a lot of transactions going on, and you need to keep hashing these things, it can cause some computational overhead. So a cache is not that bad of an idea, right? But you will see what problems it will give. It's pretty filthy. Hash. So instead of verifying this data thing, we're going to sign the hash, right? We're going to sign the hash, but we're also going to verify it. So it's going to be hash to slice. Basically just bytes. This is the hasher. Yeah. No. Yes. I think this should maybe fix it. Yeah. Look this. So, and these bugs, man, I can swear, I can tell you, you can spend months to debug them. Months, especially if you're not wrote the code yourself and you come into a company and there is a ticket in GitHub and you grab the tickets number, I don't know, 1024, and you're trying to debug this, you will literally gonna try to kill yourself because you hard. So, but actually super simple. Look at this. So what happens if we sign? Let's open up transaction real quick. If we sign, nothing. Wait. You see this. This is, again, this is the problem. Good that we see this. What the hell? We are signing the data, right? So, and we're verifying the hash. So we need to also sign the hash, right? So we're going to say tx hash. This is very, how can I say this? Advanced. But this is core. Core to understand. Calculating this hash, and then we're going to say, instead of this data, we're going to hash bytes to slice like this. So I'm going to try it again. What else going on? Let's test NFT transaction. What am I doing actually? Where is my native test? Here. Did we place this? I'm confused. I'm confused. Like this. Probably GitHub autopilot writing code. This one. Test with tamper. Okay. So it's basically still saying that it's passing. So what we're gonna do, it cannot pass, right? Wait, I'm confused. So this should be not null, right? Not null. So now our test will fail. Okay, so we have a failure because we expected it to be nil, not nil, but it's nil. That makes sense, right? So we put our hacker private public key into the to field, into the recipient, and then we're going to verify the transaction. That should return an error, right? So we are asserting that it cannot be nil. It cannot. The error should be, there should be an error. Man, sometimes a little bit confusing. But the problem actually is in this function, because we call sign here, which will generate the hash, right? Wait, am I telling the... So what I think what you should do is basically say that the hash of the transaction, which basically doesn't matter, I think, should be, because it's getting recalculated, should be a types empty hash or something. What is this? Undeclared name. Not anymore. Voilà. See what the problem is. This is the problem. Now the test is passing, so we fixed the issue. But what was the issue? Well, the issue is that although we sign here, it's setting a hash. It's calculating the hash, right? In the cache, in its own little cache here. You see, cached version of the hash here, right? But then we change the to field, the recipient, with the public key of the hacker, right? And then you're telling me, yeah, but we are recalculating the hash, right? No, because it's cached. We are still keeping the other hash, the correct hash, right? And that's why this, that's actually so nasty if you think about it. And that's why it basically succeeded, right? The hacker could locally could actually perform this attack. So what we do here is basically we say after you sign it, we basically in our test, because over the wire, I mean, you're not encoding your hash, right? Over the wire, we won't have this problem because we will recalculate the hash because it's going to be empty because it's not being decoded. But locally, it will be in memory, and then we are recalculating the hash with verify. But we already have a hash, so we don't need to recalculate it. But it always needs to be recalculated, if that makes sense. So, this test is working, right? So now we need to do the next thing. This is like a simple unit test, right? Now we go into our blockchain, which is a little bit more of an advanced test, where we're actually going to create this transaction. We're going to sign it, add it to a block, and then add a block to the chain. And it should actually also make sure that we cannot add that transaction. Yeah. All right. But the first thing, what we're going to do is open a blockchain before we do this test. Add block without validation. Here we have a problem. We have a problem because if we're going to add a block and one of the transactions is failing because due to the fact that there is no balance or something, it will basically block the whole block. It will not add a block because there is an error. And we cannot be punished by a faulty transaction. So we should actually, if there is a faulty transaction, or we need to check it way before we add it to the block, which we already do partially, but not completely, because we don't have access to our state. The only thing we do is verifying it. And with verifying, I mean verifying the signature. But we don't verify the process execution of the state transition between two accounts, right? We have a state with balances from everybody, and then after each transaction, it could be that we modify the state into another state, in state prime. So, we can quickly fix it by creating func bc blockchain handle transaction. Like this is going to be a TX, which is going to be a transaction. We're going to return an error, and then we're going to say I'm going to copy the whole shebang, paste it in here, return nil actually. Man, please can you, yes, VS Code, thank you. And then we're going to say if R is going to be BC handle transaction, the TX, if the error is not nil. So here we should, instead of actually returning, which will basically return the complete add block without validation function, we should continue. We should log, hey, yo, this transaction is completely garbage, it's not good, there is something wrong with it. Then we should continue. And something we also need to do is duplicate our state. because it could be that the transaction already modified state and then it debugged and then it bugged out or something, but the state is already being modified, and then we're going to say, yo, this transaction is basically faulty, but still the state is adjusted, right? So how we solve this is by making a copy of the state, modify that, and only apply the state at the end. So we can easily revert, right? We can revert the state. That's how we call that. But what we're going to do is we're going to panic just to see, to debug, right? We're going to panic the error. We're going to, no, yeah, or no. We're going to say, something. I know this is you will get fired if you write this at your day job, but then we know we are here, right? Then we know that we are here. So blockchain test. Bad practices, but hey. So now I want to actually see what's going on. What is this? This is this test. We're going to actually delete these. So we actually with this right now, we are 100% sure that this assertion add block should, it actually should panic. It should be a panic, but there isn't, right? And what are these actually? I'm gonna try to find these FMT and then PR. FMT PR. Maybe blockchain. No. Server network. Trying to connect. Also not. Where can it be? Validator. No. Account state. Oh my god, who's printing this? Block. Yes. Got him. Got him. Run test. Yeah, now we have clean. So we have our state printed out after each block. So this is basically a logging after the Genesis block, which inserts the Coinbase, but with no tokens. Bob Alice, and then the hacker, and this is the next account state after we performed the attack, so to speak. And then we can see that Bob has lost his money. Alice basically does not play the game, unfortunately, and then the hacker is the winner with 100 tokens. So we need to fix this. But first of all, what did we learn in the previous test? We learned that after signing, we actually need to reset this. So we're going to say hash, and I actually thinking about to completely eliminate this caching behavior, because it was fun till it lasted. Hash. Right, so now, yeah, invalid transaction signature. That's exactly what we need. That's exactly what we need. And it did not panic because we... That's a good question. I think it's in validator, right? So the validator is validating the block. And that's being called before... Oh man, this headset is hurting my ears. Damn it. So what this validate block is getting called by the validator in add block, not in add block without validation. And basically it does verify. It verifies the block, which basically does the same thing we do with the transactions. So we need to double check that. Because it could be that we could tamper with a block. And then it calculates the data hash and all that stuff. But here, in this thing, right? So we are actually looping through all the transactions and verifying them. And what are we going to do? And the data hash is also completely wrong. Because we verify the block, right? Yeah, we could actually... The problem is if somebody tampers with a transaction, puts that into a block, it will basically halt the blockchain. It will not halt the blockchain, it will basically punish all other transactions. If you have 20 transactions and one is faulty, right? What is this mosquito doing here, man? And one is faulty. Basically, all 19 others will not be included because the block will not be published, will not be committed, will not be forged. And that's not a good approach. So we need to fix that. We need to fix that also. A lot of things to fix. So this should fail, right? So that should be a not null, right? So that basically means that it's passing, yeah? And then now what we're gonna do is, do we have a BC account state? So I'm gonna say the Bob account, the account of Bob. We already have it here. Alice account is going to be BC account state, get account, and we need to give an address. That's going to be where is Alice? Private key Alice, right? Because we have a private key, we can derive the public key and the address, right? So this one, I think they should return now also. Yeah. Returns an error. So we're gonna say R, and I'm gonna say assert nil T error, yeah. Then we have the Alice account. So we're gonna, this is not Alice, this is Alice. And then we're gonna say assert equal T Alice account balance should be 100, right? And I think this is a uint64. uint64. Like this, right? First of all, we need to add a block, right? Let's do it like this. We add transaction, we check the block. Yeah. Good. Account not found. So there is something wrong. And of course there is something wrong. Yeah, because no, Alice won't. Alice does not play the game. That's true. We're not going to check Alice because we are tampered with the transaction, and Alice, we didn't create an account up front. It's not needed because you can send money. If you send money to a new address, this address is not known by the blockchain, right? But you can send money, and it will lazy init your account. That's what Ethereum does. It lazy inits your account, and that's what we do the same. So if we check the account of Alice, we won't find it because it's not lazy initted, because it's being sent. It's being halted by the chain now, right? Because we fixed the issue. So we're going to test. The only thing we need to test is that the hacker is balance Actually, the hacker account should be non-existent. So we could actually say this. BC account state. Hacker priv key. And this should be not null. I'm going to say nil so we can see that the test is failing. But you will see that the account does not exist. Account not found, you see, that's good. Can we do something like assert equal R, and that should be R account not found? Can we do this? Yeah, right, that's good. All right. That is fixed. I'm thinking. We can delete these log lines, right? Or these other working actually. Something is wrong with the ticks. Yeah. So that's the panic. I knew it will. It would notify us that something is wrong. Something is wrong with the ticks, of course, or not. I'm not quite sure. This should be okay, to be honest. What are we doing here actually? This is the signer of the block, right? This should be the validator. Yeah, then we have a priv key of Bob, we have a priv key of Alice, the amount. Yeah, I see what's going on. Insufficient balance. We are testing if we can send money from Bob to Alice, but instead of making it work, it should not work because Bob has not enough balance to send. Which actually this test should pass perfectly fine, but actually also not. And the reason what I mean by that is, if you open up blockchain, it's this, right? In my opinion, if something is wrong with the transaction, if somebody has not enough balance trying to send a transaction, it cannot halt the block. It should just purge that transaction. It should purge the transaction, not commit it, not include it into a block. So we could say fmt printf, something is wrong with the text. That's not good. We're going to say tx error %s new line and error, and then continue or something. What's going on here? Yes. What is going to do that? TX error. That's something I like, this message, right? TX error, insufficient balance. And this is account of Bob with his 99. And this is Alice. No, this is Bob. Yeah, it's Bob. This is Alice. And I think Maybe it's the same shenanigans again. Of course not. Expected value not to be null. What's going on here? Printf Alice. New line. Pref key Alice. Let's print the address. Public key address. Do the same thing for Bob. And let's see what's going on. All right. Can I delete this message? Man, what the hell's going on here? So, why are these people spamming these things, man? All right. So basically, something is wrong. What is going on here? So we have insufficient balance. The error is here. This is this one, and then we just continue. So maybe we should actually take a look at native transfer real quick. Handle native transfer. We transfer. It will return that error, so it's all good, right? Yeah. Yeah, this error is all fine. All Gucci. Value sign. Add the block. Just for the sake of debugging. So now I can see this is, yeah. This is Coinbase. So what else is going on with this error, by the way? Oh, I think it's this one. Of course. Whoa, whoa, whoa. Of course, we say not null. Yeah. Yeah. So because we do not return here in add block, handle transaction actually. Handle. Handle transaction. Come on. Here. We're not returning. We're continuing. So there won't be an error. There won't be an error. The only thing that will happen is that this transaction will not be included in a block. And maybe we should test that. How can we test that? Account state, get account. Not nil, that's true because it doesn't exist. And then we could do something like BC, get transaction, get the X by hash. What is the transaction is hash? We can do hash is gonna be calculated like this. TX hasher like this. Then we're gonna say get TX by hash. That should be TXR, but the TX won't exist because it's not included in a block normally. So we could say assert not null R. New variables. Yeah. All good. Let's see. Expected value not to be null. Do we have it then? Do we have it? Question mark. Damn, we have one. That's nasty. Print F. Damn. That's no Gucci. That's not good. How is this possible? Damn, it's this. Damn it. What we could do is shit. Not good. So the problem is, we are arranging here. We say, okay, if there is an error, we just continue, purge the transaction out of the block. Problem is, after that, and this is for our storage. This is for our take store. We store it. That's why we actually fetch this transaction here in the test. Damn. We need to. Let me try something real quick because I have no clue. I think I need to make a for loop because we're going to do some slice operations. We're going to delete something from the slice and then offset everything minus 1. It's going to be B transactions, I guess, like this. We can actually have the same logic, right? Novan, hello. Hey, man. What is up? Welcome to the stream. We can say B handle transactions. So, Novan, we are basically back to our blockchain from scratch project. And previous episode, somewhere this beginning in the week, we were implementing our own currency, right? And but we had some issues with where we could actually adjust the recipient of a transaction, and the blockchain would just say, hey, it's fine. So instead of sending to Alice, we could send to whatever wallet we want, which is basically not good. So we fixed that issue, the first tower. But of course, there are some little hiccups here and there, and I'm trying to fix these right now. Yeah. That's what I'm doing. Handle transaction. That's going to be B transactions, and then of course Y. And that should be the same behavior, right? Nothing changed. So still bad news. But I need to splice it, not splicing. How do you say that? So we could do something like BC, not BC, B. How did we do that? How did we do that? What I'm gonna do, let me quickly open up, because this is a very nasty operation, and I will show you. We did this in our exchange, right? Where is it? Crypto exchange. I will open it up. I'll show it to you. In order book. So for the people that don't know, we also created our own exchange from scratch in Golang, completely from scratch. And in this order book, we are doing the same thing, deleting from an array, from a slice, which is not the same, but still. Here, this one, you see? Let me copy this. I'm not quite sure it's going to work, but hey, we never know. So I'm going to paste it in here. Of course, it's nothing to do with the code we have, but hey, doesn't matter. So we could say something B transactions. Y is this, and let me say len. B. What's going on with VS Code, man? B transactions. Y. No. -1, right? And then almost the same thing. We're going to say this, offset it with 1. So basically, transactions, do this, -1. Yeah. Normally, that should basically delete this transaction out of the loop, out of the slice. I'm gonna let them sit for a bit. You never know. So if we are back here and ranging through the same transactions, it should not store it because it's not in the slice anymore. Please let it be. Insufficient balance, let it be. Yes, you see, it's working. Yes. That's good. So now we don't have an error anymore, because the transaction we are trying to fetch from the TX store is basically nil, right? Get TX by hash, so we could say, to make this test better, we say error is this, and then we say not null error, right? Nice. Fixed. Let's clean it up, eh? Do we have a logger? BC logger log error. I'm gonna say R. The question is, does it log the error or not quite sure if it can. Hi, Caraga. Anyway, it doesn't matter. Not quite sure if our logger can actually interpolate a string from an error. I don't know. Maybe it can. All right. And now this nasty thing. This lock. This can be good to know. Tighten up the locks. All right. I think we have some more errors actually by this refactor make run. No. Make run is basically run in the blockchain. It's all good. We need to make test. Make test. And we have some fails. The question is, what's going on? Test takes in code code. Yes, of course. I was expecting something like this. This is failing. What's the difference? It's the hash. You see the hash is empty, which is normal. Takes en code. Nieuw GOP takes encoder. With signature, that's the thing, right? The signature is not being... Ice bear. Minimum, how many hours should I give for learning? Man, Ice bear, like I told you before. Learning is a lifetime process, right? You never stop learning, you know? Depends, man. You're just started out, right? Ice bear, you just started out. Give it some time, man. You cannot expect to compare yourself with me or something. That takes time. It is. Put in the hours, man. Put in the hours. The more hours you put in, that's the better it will be. That's the faster it will come also, right? Give it time. Day by day, it will be fine, man. Trust the process. That's very important. Trust the process. Sooner or later, things will it will happen, man. Keep learning each day. Keep raising the bar, right? That's important. Keep raising the bar. What I was doing here, I think I'm gonna reset this hash. Like this. What's going on here? I gave almost 2 hours a day. That's good. 2 hours a day is perfect, man. That's actually very good. 2 hours a day. That's 14 hours a week. That's good. Keep doing that. Keep building stuff and trust the process. Run test. Yeah, it's this hash thingy, and this is cock blocking so many things. It's the GOP encoding, man. You know what I'm gonna do actually? I wanna delete this caching, the hash caching. Because look at this, an error, and the reason is actually because in memory, why did it actually work in the first place? This could never work. So what happens is that we make a transaction with a signature, which basically will generate the hash, put the hash into its variable, right? Into the hash variable in the structure. And then we're going to encode this to bytes. But the hash won't be encoded. It won't, right? Because we can calculate that back over the wire, right? So you serialize something into bytes, then you send it over TCP connection. On the other hand, on the other side, a node picks it up, decodes it back into a transaction, and then recalculates the hash to verify. But in memory, here, we compare two transactions with each other, which should be equal, but the hash, the first one, the hash won't be 0, and the second one, the hash will be 0. So in order to make this test pass, the only thing I need to do is what I did before, is basically say that the hash is going to be an empty hash, which is types hash, right? Or actually what you also could do, I think, is this, empty bytes. Rashid, thanks, man. Amazing work. Thank you so much. Empty byte is not working apparently. Doesn't matter. We say types hash like this and call it a day, and this test should work. Good. Okay. What else? What else? What we're also going to test, right? We just fixed some attack vectors on our transaction, but we should also test some attack vectors on our blocks, right? Because you can alter with the transaction, which we did, which we fixed, but you can also alter, you can also tamper with a block, right? You could delete transactions from it, you could add some to it, you could, for example, I don't know, change the address of the validator so you get the reward, something like that, right? But we need to check that also. Make test. Let's see. This one. Was it this one? No. This one. What the hell? 49. Test NFT transaction. Yeah, of course. Our chain also can understand native NFTs instead of using smart contracts, which causes all these bugs. And to be honest, and to make it clear, this chain is educational purpose, right? Educational purposes. There is no need to replace other platforms because there are already too much stuff going on in the space, right? And nobody is actually completing his project decently. So that's why I think people should stop making all these new blockchains with this little bit of feature, this tiny little feature extra, right? We should all collaborate to make one thing very good. But you know how it goes in life, right? The more people collaborating on a project, the slower it becomes. Because everybody wants to do his thing, and politics, man, politics kills us, kills the whole world. All right, so, but this is not the politics channel, so we can do whatever the fuck we want, right? What is going on here in this test? Nothing much. So we expect this transaction with a, and we get whole chunk of bytes. So we generate a private key, we make a transaction, we sign it, and then we say a new buffer, encode into the buffer. Yeah, it's again the same issue, right? It's again the byte issue. So we need to say takes hash is going to be types hash empty, right? Yeah. Now I know why it worked before, because we actually yeah. The hash of the transaction was basically the whole structure, which is not good. So we rewrote this a couple of minutes ago. But hey. All right. Make run. No, make test. Man, this is account status actually. All right, now we can see what is going on. Block test. Test decode. Yeah, it's the same thing. Is it the hash? It's still 0, that's good. What is wrong here? It's the header, it's another pointer. You see this? This is a memory pointer and this is a memory pointer. And we are comparing them. You cannot have the same pointers. Well, you can, but it's a different structure, right? So we are comparing this block with a new block. So what we do in this test is very simple, right? So we basically create a random block, randomly for testing, random block. We encode this into bytes, and then we decode this back into a new block, which is bdecode. But header is a pointer, so the first block will have a pointer, which is a 8-byte integer. Well, memory thingy. 16, 8. I'm confused. 8-byte thingy, and pointing to memory. And bdecode will have the same thing, but it's not the same. It does not point to the same memory address, if that makes sense. And some crazy noises in my house. Not quite sure. Maybe I'm getting robbed or something. But hey, go ahead. I'm streaming. We'll deal with you later. Why did these tests work in the first place? That's what the hell is this? It's good that we actually revisit this and fix these things. It should be the same header. That's the thing. How can I do this? Percent plus v, new line, header. Let me quickly see what's going on here. Version, yeah. Should be the same thing, right? Where's my other header? Nil. I was looking for my header, but ay. Yeah, of course, because I'm literally the most. So, yeah, the header is completely the same. It's just a pointer. Yeah. Oh, man. The question is, what happens if we do reflect deep equal header and be the code header? What would happen? Yeah, that's working. So why is assert not working? Yeah, I know, I see. Because if we do reflect deep equal, because I'm pretty sure testify assert will do the same thing. And we do BD code, it will be the same. It will be false, because I'm pretty sure testify will do the same as reflect deep equal thingy, just like we did. All right, so it's actually, the test is failing, but it's not a problem. The question is, how do we deal with this, right? With a test that's failing, but should actually pass, because how do you deal with something like this? So you know what? We're gonna say this. We're gonna do it the long way then. Equal. We're gonna say t b header should be the same as b the code header. Yes, like this, and then we're gonna copy this a couple times and say transactions. The same thing here, and then what do we have? Validator. Like this, and then signature. The hash we don't care. The hash is Since when is this actually? Why these tests are here for forever? And suddenly they stopped working. Can you imagine? And probably transaction is the same thing. Actually, we could do something like this, right? Len asserts equal man t that should be and then delete this. Yeah, of course, now the transactions, oh man. Wait. It's the hash, right? It's the hash of this thing still in memory. But after we decode things, like I mentioned, the hash will be 0, but it doesn't matter because it's getting recalculated all the time. But we have our caching system, blah, 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 and that's cock blocking us the whole fucking episode. So you're going to say b transactions hash is going to be this is so hacky, but yeah. Okay, and how Man, sometimes. All right. Let me quickly check. Cool. Hey, sometimes a little bit of testing, bug fixing, why not? Make test once again. Look at this, the whole suite passing. Coolio. I think it's always a good way to do a git add and then a git commits. And we're gonna say fixed the X tamper issue and fixed all tests. Hop, hop, and then we say git push origin master. Hop, okay, done. All right, let's do a clean thingy, clean start. Close all editors like this. Open up main. I'm thinking, what was a let's take a look at blocks actually. Well, you know what we're gonna do? We're gonna do the same attack on a block and see if it works. See if we can hack a block. Block test. Boom. Block test. We're gonna make a new function for this. Test block. We're gonna say test verify block with tamper. I don't know if tamper is the right word for this, but hey. Testing T, and then we say hop hop. Sometimes my functions disappear. We do the same thing like here, right? We can actually copy some things. Priv key, assert. Yeah. I think we already tamper with this, right? We can. I think this is kind of. Oh man, I trained legs yesterday and I'm still sore. Can you imagine? I think this test already tampers with a block. You see? Because we make a block. We sign it, we verify it, all working fine, but then we make another private key, replace the validator, and verify it again, and shouldn't work. But this is retarded. This is not gonna work. Because if this will fail, this will fail. I mean, what is this? Who did this? So we can actually try to modify something else. Wait. We could say test verify block to make this actually nice. Test verify block tamper validator. Like this, and then actually we could copy this whole test. Paste it in, delete this one. Test verify block tamper validator. We're going to say tamper height or something, right? Maybe somebody want to adjust the height. So instead of we're going to say b header height equals, I don't know, something that cannot work, and then we're going to say assert null, not null actually, t b sign yeah, with the priv key. No, verify. What the hell am I doing? Verify, b verify. That's what we need. Verify like this. not, that will not work. Not null. This is actually... So we adjust the height, right? And then we verify the block again. And then it just tells us, yeah, it's all fine. I know why it is. It's this thing. Actually, we need to reset the hash, I guess, once again. Types hash. Is it? It isn't. Which is very concerning. Yeah, then we need to check what is going on. All right. Go we go. Yes, Victor. That's exactly what it is, man. How is your day? What did you do this weekend? I hope you had an amazing time. Tomorrow's Sunday. So we verify. So we say signature. Yeah. Signature verify. We verify the B header bytes. That's true. That's correct. But the B header bytes, the block header bytes, you navigate VS Code like Sonic the Hedgehog. Oh man, I can do. Yeah, man, it's muscle memory. You can do the same thing. You just need to do it. Just need to get used to it. It's the same thing if you play a game or something, right? Like League of Legends or World of Warcraft. You play the rogue or something. Your combination, it's the same thing. You will suck in the beginning and you will panic and you know what it is. But after a certain period of time, you'll get used to it and you don't think about it. Although sometimes I think about it. If I'm typing and some people are watching me, then I'm trying to do my best. And the harder I do my best, that's the worse it gets. You know that feeling? Well, it is. Because when I'm off stream, I'm actually I'm maybe double as fast just because I'm just chilling, right? But that's how life is, right? You need to perform under stress, isn't it? So basically, we have an issue, right? So for the people that don't know, we are creating a lot of cool stuff in Golang from scratch, a lot of Web3 blockchain stuff. And this is the blockchain in Golang from scratch, which is a complete series where I live coded every single byte of this thing from a blank page. And right now we are trying to test some attack vectors of transactions, which we already fixed. And now we are actually trying to modify blocks and trying to verify them and see if it works. And some tests are failing that actually should not fail. So what we do here is basically we create a random block, we sign it, we verify it, all good, and then we say the height is going to be completely different, and then we verify it again. And it's not null. It should not be null, right? It should throw an error. Throw, return. But it is. Okay, so header bytes. Why is this error not being returned? Should we panic or something? Of course. Why not? Normally you cannot panic, right? Panic is bad, but I mean, panic is bad, but you need to think about the fact that if you ask for bytes in a very secure environment, and you ask for bytes, and it's, what do you want? Do you want to, what you gonna do if you fetch that error? What you gonna do? It's like trying to walk with 0 legs. It's just impossible. So then you can better just sit down forever. I mean, the same thing here. If we ask for bytes to do very secure computational stuff and we don't get the right bytes or there's an error, then we can just panic and shut down the whole system and fix these things, right? Of course, most of the time you cannot panic and you need to handle the error because there are some logic you can do. If there's an error, I need to do this. If it's that error, I need to do that, right? But in this case, we are literally completely paralyzed. So then we can just panic. Better panic than just not handling an error, right? Because then you know nothing. I get you, sir. It's all good, Victor. It's all good. Encoder encode the header. Height. I mean, you cannot, this cannot be true, right? I mean, what's the version of this thing? fmt print f, no, ln, b version. What is this? 1, okay, cool. So let's say, instead of this header, let's say version 1000. It's the same thing. What the hell is going on? So we are hashing this thing. Isn't it? Hash. Here. We hash the header. B header. B bytes. Wait, maybe I'm just too confused. What is this? Let's do... I'm not sure what's going on actually. It's a long time I visit this part in the project. Let's print the hash. Like this. Where is my test? Here. What's going on? I'm completely lost. My compass is somebody has a magnet. It's tricking me with a magnet. I'm completely lost. I'm gonna lie. Sometimes you need to be honest. Sometimes you need to be honest with yourself. I need to reset real quick. How can I reset? So verify is returning OK. There is no error on verify, which it should. Because if you call verify, it should recalculate the hash. Wait, can we... You see, b header bytes, right? So it's calling bytes if we verify. But if you do the bytes of a header here, if you modify it, can we do something like encode to string b header is which is the hash actually, to be honest. Not the bytes because it's a SHA-256, right? Hex and go to string. That should be this. Yeah. And this is the most... I'm gonna copy this. You see? It's not the same, right? This is a nice trick in VS Code, that you can compare these things, right? If they, you see? So these are okay. I think the whole line above is okay. Bytes. No, it isn't. Yeah, it is, right? In my opinion, they're actually exactly the same. Stop it. We missed something. Here. See this? So here, and then we have this 1010 above. So they're not right. That's the header. That's exactly what, that's this version we know. Man, I'm completely, I don't know what's going on. And I really want to find it actually. I'm trying to think, but I can't. Println b. I'm gonna do this. Right. That's not gonna work. Clear the cache. Hash is going to be types hash like this. This is a complete new hash. What the hell? Yeah, of course. Yeah. That's not looking too good, or maybe I missed something very, very small. Probably something like that. It's most of the time always something like that, right? Let me quickly see. And the reason why we didn't catch this before, although we have these encoding decoding tests, is because we made a bad test. We made a very bad test. So testing is good, but sometimes, I mean, testing is also writing code. So if you can write mistakes in production code, you can also write mistakes in your tests. That's a thing. So in my opinion, I was discussing on Twitter with somebody about AI that could auto-generate code. And my tweet was, if you use AI to generate your code, you're trash. But if you could use AI to generate a test from your code, that would be insane. That would be legit insane, because writing a test a good test is sometimes. So if you could have like a system that could introspect your code and could write a test, man, that would be sick. Holy crap. If you can invent that, you're literally rich. And maybe it already exists, but you know how it is with these AIs, right? It exists, but it still doesn't work too good, and probably only Python or something, or only JavaScript. These languages where they can train a lot with a lot of data, right? Okay, so I need to, sometimes if you're stuck with something, right, you just need to go away, go outside, do something else, and come back with a clear mind. Because your thoughts are still dwelling in this code, right? But maybe we should give it a better chance. I'm not giving up. So we're gonna say, we're gonna comment this. We're gonna rerun this test. Wait, this is gonna fail, right? Because like this. You see, this gives you a better feeling already because the test is passing. And who is printing this thing out? FMT. Brr. No clue. Maybe in hasher. Hasher. Just double checking. Block. No clue. So we could do something like this. We make a block, right? We could say, yo, it's the header. We know the header is the issue. So we could say the header is basically the B header, right? That's what we know for sure. We also know that the bytes of this header is going to be, do we have this? Bytes, yeah. All right. All right. Let's say we modify this. Actually, why don't we do what is this, a pointer? Bytes. You're not gonna tell me that this bytes. Yeah. You never know with these pointer tricks. They're comparing the same thing all over and over again, looking your whole life to find this issue. It's like a girlfriend. Luckily, I found one. Took me long. Took me 35 years. All right, so B header version. Yeah, I'm gonna try something. Let's say bytes compare. Wait, the result will be 0 if A equals. Yeah, okay, cool. Bytes compare B header. And then we're gonna compare. I don't even know why we're doing this because I already know that it cannot be true, but still. Cannot return the same bytes, right? Cannot return the same bytes, yo. -1. Of course -1. Of course it's -1. Right? But if you do this, then it should be 0. Exactly. So why does this verify work? right? Expected value not to be null. Of course not. It's in this verify method. It can. Shit, it was the same file. Nasty. B validator, B header bytes. Wait, what we could do, we could, wait, I have an idea. Oh man, look at this. We can say print f, and then this verbose v with the new line, of course, and then say the header. So it's gonna actually verbose log this thing. Verbose log, yes. And we call this 2 times, right? We call this here, right? Verify, so it's gonna, intellectual property, sir. Yeah. So we're gonna call it 2 times. Yeah, this is, hey, you see, it's different, eh? It's good. This is all the same. Even this timestamp, yeah. So why? I know why. Programmers is a real thing. It is, but I know why this is. This is actually. No, we signed. Man, this is legit the biggest. I know what's going on. Holy crap. Or not. Oh man, please somebody kill me. Oh, programming, man. I thought I had a eureka moment, but it isn't. Of course, it cannot be. This cannot work. This cannot literally not work. Because we signed this random block with the private key. So it's going to have a iceberg. So it's going to have a signature. The signature. And then we modify this so it's a complete different message. Why is this working then? Wait. Okay, so what I'm gonna do is this. Oh man, this is one of the nastiest things I'm working on. Mr. Brown, what's your thoughts on Aptos? Oh yeah, Aptos, smart people. Very smart people, very promising team. But the problem is, like I said, it's very early to see, because I mentioned this in one of my couple streams, where the success of a blockchain basically is not being determined by the technology, right? It's being determined by the user adaptability for us developers, right? Because if you wanna, for example, if people come to Ethereum, but Ethereum is already a very well progressed blockchain over the years. So, but if new people come to Ethereum, they can instantly boot up a private blockchain. They can scaffold a complete Web3 app, working, everything okay, instantly, right? So that gives these people a lot of dopamine directly from, whoa, I can do Web3, it's insane. And that they will keep going, right? They will keep going, they will tell everybody on the work, James at the water cooler, basically can just write 2 lines of JavaScript and whoa, suddenly he's a Web3 developer, right? And that's good because it will drive adoption. Although maybe Aptos can be, from a technological standpoint, much better than Ethereum, right? Maybe much more scalable and I don't know, all this cool stuff these guys have because that's new technology. Ethereum is already a couple years old. But the problem is, if James at the water cooler cannot open up his editor and boot up an Aptos app, whatever, we are in trouble, right? That's the thing. Same at Solana. Solana is an amazing piece of technology, but try to write a smart contract without killing yourself, right? That's the thing. That are my thoughts. The technology are pretty nice. But same Cardano, smart contracts, I don't know. Cardano, same thing. Haskell. Are you going to write in Haskell? I'm not going to do this. So that's the thing. It's the same with startups, right? You can have the best startup idea, right? You can solve the biggest gap in the market, right? You can literally have a solution that solves the biggest gap in the market. But if you cannot sell your idea, if you cannot market your idea, your startup is literally doomed to fail. But if you have a bad startup idea and you only fill a gap for 3 people, but you are the biggest marketeer, you can trick people, you can sell dead cats, then you will make money with whatever you're doing. You can even sell shit in a bag and you will make money, right? That's the thing. Same with blockchains. If that makes sense. And this is a very long answer. So the programming language is an important factor. Yeah, I think so. It's very important. Well, maybe not the programming language. Like, for example, Solana is Rust, right? And Rust is okay. It's not an entry-level programming language, but still, it doesn't matter, right? If you, like I mentioned, programming is easy, right? Like learning a programming language is super easy. It's solving the problem that is hard, right? That's the hard part, right? Because once you know one language, for example, if you know Python or you know C, or one of these generic, not generic, but one of these main languages, then you can easily infer some other language, right? You can easily write Ruby. For if else, it's all the same. Declaring variables, it all kind of works the same, right? You just need to memorize the syntax a bit and it can take a couple of days, right? But so for Solana, it's Rust, so that's okay. But the debugging process, man, no error messages, bad error messages. No documentation almost. Terrible. Literally terrible. And you can think it's improving over time, but with Solana, I'm not gonna lie, I'm already programming for 2 years in Solana. I do a lot of contracting work. And 2 years ago, it's exactly the same thing as now. So it basically didn't actually evolve. The same error messages you're literally gonna get anxiety attacks from. And maybe Near, right? The Near protocol, I checked it a little bit, and they have already some good documentation and some good stuff going on. So I see Near is going to be a big competitor if they can keep pushing out and this stuff. And for Aptos, it's very early, right? They just launched. I mean, come on. Give these guys a break. We will see in a year, right? We will see in a year. We will see. As long as a team has no developers in suits, then it's all right. Then we have a good chance. But if once you see on a project his team and there is some guy, blockchain engineer, blockchain specialist, and he has a suit on with a tie, you need to peace out. Bad news is coming. Bad news is coming. Yeah, so we have this issue. Wait, I'm going to try one more thing and then I'm going to wrap it up because I have some stuff to do. I'm going to do something very stupid, right? I'm going to say something like byte. Actually, can I do this? Probably not. Probably it is. What is this tamper thing here? Okay, now this works. Okay, cool. I'm gonna debug this probably on another stream. So, because this is, I don't know what it is. This is Illuminati. Sometimes it is. Sometimes this shit happens, man. All right. So if somebody has questions, please feel free to ask. I can have some 5 more minutes or something to answer some questions. It doesn't matter. It can be any single question about blockchain, crypto, whatever, man. Programming. It doesn't really matter. Ask me and I will answer. And if you did not subscribe yet, please consider doing, because look at my channel and judge for yourself. And hop into the Discord, because tomorrow, if you're not in our Discord, please do it, because tomorrow I will release some insane news. Yeah, very good news, especially if you're willing to learn and want to make money. You need to be in the Discord tomorrow or subscribed. Something like that. So I will wait and chill a little bit for some more questions. And if there are none, then we're going to wrap it up. And probably I will be back tomorrow like usual. Let me quickly see. Waiting for questions. What we did in main. A lot of shenanigans. Wait. First of all, I'm going to revert this. Like this. And then make a run real quick to see if it still works. And so for the people that don't know, I also made a complete crypto exchange from scratch in Golang, which I'm right now, which actually completely done, attached with real hot wallets to an Ethereum private blockchain. Matching engine order books, we can fill market orders, and we actually transferring real Ethereum tokens based on the private blockchain, of course. And I'm right now writing the front end, which looks trash, but still, hey, I do my best. So we can actually place market orders from the front end, and then it's completely done. So if you want to learn how to build that completely from scratch, everything, not only a front end, but the complete exchange, order books, matching engine, you should check the channel, the playlist. And we're also building a poker game, decentralized in Golang and Solidity. Like I mentioned, what you're gonna see on my channel, you will never find it, never ever, on no other channel. Nobody in the world is doing what I'm doing. Check my channel and change my mind. Prove me wrong. All right, so thanks everyone for watching. Like I mentioned, please consider subscribing, and I'll see you in the next video. or borrow in the next live stream. Thanks for watching. Bye-bye.